In this presentation, we will look into the most common boundary scan instructions. At the end, you should be able to list the most important instructions to explain how each instruction affects the operation of the boundary scan infrastructure, and also how the process of loading a new instruction can also be used to test the integrity of the boundary scan chain. Or in other words, to check if there are any faults in the TDO, TDI, TMS, and TCK interconnections. External test is the main mandatory instruction and is used to detect shorts and opens in the printed circuit board. This instruction will place the boundary scan register between TDI and TDO, so the instruction decoder will set the data multiplexer as shown here. Notice also that all the boundary scan cells are set to test mode or controllability mode, and will therefore isolate the pins from the core logic. External test has a predefined code that is all zeros. So this will be the selected operating mode if the instruction register is loaded with all zeros. Sample and preload, which in earlier versions of the standard consisted of one single instruction called sample/preload, also select the boundary scan register, but the difference to external test is that in this case the boundary scan cells are set to transparent mode, and therefore all the pins are connected to the core logic and the circuit will operate normally. As two separate instructions, they are used to do what their names indicate. So sample is used to capture the logic values present at the parallel inputs of the boundary scan cells, which can then be shifted out for observation. And preload is used to shift in and load the output stage of the boundary scan cells with the initial values that will be sent to the output pins when the external test instruction is loaded. Finally, bypass will place the 1-bit bypass register between TDI and TDO in the case of those devices that we do not wish to access. All the boundary scan cells will operate in transparent mode when bypass is loaded. This instruction also has a predefined code, which is, in this case, all bits at 1. Moreover, it is loaded automatically when we power up the board to ensure that the boundary scan infrastructure will be transparent at startup. There's a number of optional instructions that may or may not be present as we go from one device to another. RunBeast is meant to activate built-in self-test features if they exist. ID code is used to read the optional device identification register, high set to set the outputs to high impedance, etc. We may see other examples of optional instructions in the datasheet of the Texas Instruments devices that are considered in this course. Before concluding, there are 3 things that I want to tell you about the instruction register. Similar to what happens in the case of the boundary scan cells, the instruction register cells also comprise 2 stages. The output stage will be simpler in this case because there's no output multiplexer. The input stage, however, also alternates between capture and shift modes, as we will see. And since we have 2 stages in each instruction register cell, capture/shift and latch, as in the boundary scan cells, the output stage will hold the code of the previous instruction while a new instruction is being shifted in. And this actually answers the first question in this slide. The second question addresses illegal boundary scan instruction codes. If an instruction register has 8 bits, as in the case of the Texas Instruments devices, not all instruction codes will be used, and actually most of them will be illegal. If one of such codes is loaded into the instruction register, we may expect it to default to the bypass mode. And last but not least, an important feature defined in the IEEE 1149.1 standard is that when we shift something into the instruction register, its capture shift stage will automatically load a pattern that contains 0, 1 in the 2 bits that are closest to TDO. So as we shift in the first bit, a 1 will show up at TDO, and as we shift in the second bit, then the 0 will show up, and then the remaining bits, possibly all 0, will show up. Well, this requirement is important because it toggles every TDO to TDI interconnection, since TDO is initially driven to 1 and then driven to 0. If there is any short or open fault involving the test access port pins, these 0-1 sequences will not show up at the port TDO, and in that case we know that something is wrong with the boundary scan chain itself. This is what is called the integrity test of the boundary scan chain. And that's all. Thanks for your attention.